Now I'm inside of a DNS record. This is just an A record I have in a test zone. It's not a live zone, so I'll be digging directly against our name servers to get a response from it. And what I want to emphasize here is the filter chain. So this is what NS1 uses to really allow us to build out these advanced traffic steering profiles to take advantage of the different use cases that we talked about today. You'll have all of these different filters here together. And the way that they work is they'll either be removing or sorting the answers that you have in your DNS record till we get to that perfect either IP address or host name that we're going to be sending to that user. So I just have a few different IP addresses, just some test ones pre-configured inside of this record. Typically for a DNS record that's going to be using a filter chain, you're going to want a TTL maybe around 60, 30 seconds so that users can see that there's been changes in the DNS response. And what we can walk through today is a few of the examples that we talked about and how you can build out these filter chains pretty simply here. So we have a few different categories. The geographic ones are going to be sorting the list of answers. GeoTarget is going to be examining the user's client subnet information. And then we cross-reference that with a hybrid geo database. The fencing filters more draw a circle around your regions. So we can fence based off of things like network or country, different regions. Health checking filters, of course, to account for the availability of your different endpoints and your different web servers and data centers. And then some regular traffic management filters that work well in conjunction with the other filters that you see here today. So for our active failover use case, typically we're going to start off with our up filter. So I'm going to drag and drop that to the top here. The next filter I'm going to utilize is priority. And then lastly, I'm going to use select first end here. So let's walk through this. This up filter first is going to be examining the up metadata of each of the answers. And all up will do is remove answers according to the health status that we have here. So this will be true or false, up or down. We can set this statically here in the portal, or we can take advantage of monitors. So we have the ability to ping your individual endpoints for you using a variety of different protocols. And you can also just simply use our API to change the status as well. So I'm going just to connect this to a monitor that I already have pre-configured inside this account. So now this IP address will only be served according to the health of this monitor. I'm going to go ahead and continue to set the up status for the other answers that I have. So now all of my answers have the appropriate metadata for this filter. And now I'm going to move on to the next one. So with our priority tier filter, we're able to designate different tiers, 0 being the most important, 100 being the least important. And with that, we'll only serve answers out of the lowest tier. So if I wanted to designate my primary data center with this tier, I can just set that there. And then for my secondaries, I'll go ahead and put them in the next tier. So now only this IP address should be served as long as this monitor is up. If this monitor fails, then we'll fail over to the next tier. So what I'm going to do is just go ahead and hit save. And over here on the left, all I'm doing is digging against this record every couple of seconds so you guys can actually see the response happening. So like I showed here, only one IP address is going to be served because only this one is available in this tier. And then lastly, the select first end filter will remove all but one address, and this is configurable as well. So in the event that this monitor were to fail, we would fail over to the next tier. What I can actually do is just set this to false, hit save, and now you can see that we failed over to the next tier available. So 5.5.5 is being served simply because we have the select first end. So really easy to set up. I just dragged and dropped a few filters here. And now I can account for the availability of my endpoints, designate primary and secondary data centers, and I can do more interesting things with grouping and shuffling if I'd like as well.
Is
So
there
I'm
any
going to move
limit to
in.
the number of filters
Mhm.
you can use on these chains?
So you can actually have as many filters into these chains as you'd like, but typically a normal filter chain would have around 3 to 5 filters.
Okay.
So what I'm doing now is just removing the priority filter, and we can move into our next use case utilizing the weighted shuffle here. So similarly to the priority filter, weighted shuffle is going to be looking for its own metadata. If I click onto the filter, it'll reveal it here. And this will allow me to set different weights for my answers. And the way that these work are they're simply just proportional to the sum of all the weights I have set. So I can total these out of 100 just to make it easy to follow. I'll make this answer up so it can be served. And now what's going to happen is we'll simply check the up status. We see all the answers are available. Second, we're going to use the shuffle, and we're only going to shuffle according to the weights. So with 5.5.5 having a weight of 50, you can imagine it's going to be at the top here 50% of the time. 4.4.4 will be 30% of the time, and then 6.6 would be at the top 20%. Resolvers are normally only going to pick a single IP address, so that's why we have that select first end filter here. So once we're done with our traffic steering logic, only a single IP address will be served. So these are really easy to set up like I've done here. You can do it in the portal or via the API. We also have a few different SDKs available and a Terraform provider, so different ways you can have your filter chain set up as code as well. So the last use case I want to show you guys here is going to be utilizing a few different filters to take advantage of the VPN traffic steering. So we'll, as a best practice, keep that up filter in there in case you want to quickly eliminate any answers. I'm going to utilize the geo target country filter here. And then I'm going to use the shed load filter. So this filter will allow us to feed it metrics so that we can shed answers, well, traffic to or away from your different endpoints according to the values that we have set. And then lastly, select first end. So let's set this up. First, I have my up metadata. The next thing I'm going to do is set different states for my VPN endpoint. So let's say I have a VPN server in New York. I can just tag the location there. I have one in Texas to serve my central US offices, and then I'll do one more in California. So these will designate my different VPN endpoints. And then next we have our shed load filter. So what I'm going to do is actually set the metadata for this one at the record level. So this will just ensure that all the answers inherit the metadata that I'm setting. And the way that the shed load filter is going to work is it's going to be looking for a high watermark value and a low watermark value. So let's say for the number of connections that each of my VPN servers can handle is 100. I can set the low water mark to 0. And each one of my endpoints, I will be feeding, let's say, the number of connections to it via API. So I'm going to just set my filter chain to look for active connections. And this is a value that I can, feed to us via the API. I can have my Cisco ASA device feed this to us via SNMP. But for example's sake, I'm just going to set the value here manually. Let's say this one has 50 active connections. This one has 20. It's a bit more available. and this one's running hot at 90. So now I have my shed load set, select first N. I'm going to disable this just so we can see the shed load actually doing its work in the background. I'll just go ahead and hit save. So now with this filter chain, first we'll examine the up status of each answer. Next, we'll sort according to the location of the user. I'm based out of New York, so typically 4.4.4 is going to be the first answer for me. And then we're going to actually account for the load of that particular endpoint. So perhaps this VPN endpoint is a bit overloaded. It's early in the morning, everyone's logging in. Just because it's closest to me, we don't want to send me there if it's unavailable. So with it having the amount of connections at 50, our filter chain will account for that and remove it out of here every now and then, just because it's about halfway full. Since California is at 90, you can imagine it's going to be shed here the majority of the time. It will appear every now and then, but if it does go over that 100 value, it will not be served. And then select first N, of course, just ensures that only a single IP address is served to that user, and they will connect to that endpoint. So just as simple as that, you can walk through a few different filter chain configurations that you have here. You know, I mentioned they're typically only about 3 to 5 filters long. This is actually one of the more complex ones, but you can definitely take advantage of the different filters you have here and test and play around with the behavior and get more comfortable with it.